This is Dr. Meena Sahay, continuing my lecture on Kronig Penney model. We had done equation 1 and 2. Now, assuming that the kinetic energy E of the electrons is less than the potential energy V0, so we put alpha squared is equal to twice me by h cut squared and beta squared is equal to twice m by h cut squared V naught minus E for the two different regions. So that equation 1 becomes d squared psi by dx squared plus alpha squared psi is equal to 0, equation 4, and d squared psi by dx squared minus beta squared psi is equal to 0, equation 5. Now, according to Bloch's theorem, the possible solution of these differential equation क्या होगा? Psi is equal to E plus minus I kx u kx, equation 6. अब इसको हम differentiate, ये equation 6 को दो बार differentiate करते हैं with respect to t. एक बार क्या आ जाता है? d psi by dx, I get this right hand side and this is my equation 7, and I differentiate it again, d squared psi by dx squared, I get this right hand side. This is my equation number 8. Now, substituting for d squared psi by dx squared from equation 8, in equation 4 and 5, I will get two equations, d squared u1 by dx squared plus minus 2ik du1 by dx plus alpha squared minus k squared u1 is equal to 0, 9, and d squared u2 by dx squared plus minus 2ik du2 by dx plus beta squared plus k squared u2 is equal to 10, where equation number 10, where u1 u2 है values of u kx in the two different regions. हमको दो region है, एक 0 to less than a and 1 minus b less than x less than 0. अब solution of these equations are u1 is equal to a ei alpha minus kx plus b e minus I alpha plus kx for the first region, and u2 is equal to c e to the power of beta minus ikx plus d e to the power of minus beta plus ikx for the second region. So equation number 11 and 12, where we have this a, b, c, d, the constants hai, which must be chosen in such a way that the following conditions are satisfied. कौन सा है continuity equation का? तो u1 at the boundaries x equal to 0 is equal to u2 as x equal to 0, same with the differential, and that is equation 13, and u1 at a, this is for the periodicity, and is equal to u2 at minus b, and same with the differential, and this is equation number 14. The first two conditions given by equation 13 are required for the continuity of the wave and their derivatives across the boundary. The other two conditions, these two conditions for equation 14 are required because of the periodicity of UK. Applying these conditions, क्या आ जाएगा? A plus B is equal to C plus D. This is equation 15, and AI alpha minus K minus B I alpha plus K is equal to C beta minus IK minus D beta plus IK, equation 16. And from the last two conditions, we get this equation 17 and we get this equation 18. So I have four variables, and I have got, 4 equations and 4 variables, A, B, C, D, 4 constants you can say, and they can only have the solution if the determinant of the coefficients vanishes. That is, the A, B, C, D can only be folded. Now, so what I do, I have this, this is here, I have taken the determinant A, B, C, D, first wala tha, to 1, 1, 1. I have taken the coefficients of the the determinants. So 4 equations say A, B, C, D ka, and I have equated it to 0, and which on simplification gives me, when I open out this determinants, beta squared minus alpha squared by twice alpha beta sine hyperbolic beta b into sine alpha a plus cos hyperbolic beta b into cos alpha a is equal to cos k a plus b, equation number 19. Now, equation 19 can be simplified by assuming that as b tends to 0, v naught tends to infinity. V naught क्या था? Potential था, b था मेरा periodicity, but the product VOB remains finite. Under this condition, we have sine hyperbolic beta b tends to beta b, cos hyperbolic beta b tends to 1, and beta squared minus alpha squared is just equal to beta squared. So, ये जो equation 19 था, this just reduces to beta squared by twice alpha beta into beta b sine alpha a plus cos alpha a is equal to cos k, और इसको जब हम simplify करते हैं तो मेरा ये equation number 19a मिलता है, that is we have P into sine alpha A by alpha A plus cos alpha A is equal to cos Ka, and this is 19A, where P is equal to beta squared AB by 2, and this is m V naught AB by h cut squared, equation 20. P is a measure of the area VOB of the potential barrier. Increasing P has the physical meaning of binding a given electron more strongly to a particular potential. Now, this equation 20, I can then solve graphically by plotting its left hand side against alpha A. ये देखिए, यहाँ पर हमने अल्फा ए लिया है इस पे, और यहाँ पे लेफ्ट हैंड साइड है पी साइन अल्फा ए बाय अल्फा ए प्लस कॉस अल्फा ए को वाई एक्सिस पे, एंड फॉर एनी आर्बिट्री वैल्यू ऑफ पी से पी इज इक्वल टू 3 पाई बाई 2. ये फिगर 3 में देख रहे हैं. सिंस -1 इज लेस देन इक्वल टू कॉस के इज लेस देन इक्वल टू प्लस 1, इक्वेशन 20 इज सैटिस्फाइड ओनली फॉर दीज वैल्यूज ऑफ अल्फा ए, फॉर विच द लेफ्ट हैंड साइड हैज वैल्यूज बिटवीन -1, ये जो दिख रहा है ये लाइन, एंड दिस इज +1, एंड दिस इज फॉर -1. सो नाउ दिस फिगर 3 से हम लोग को कुछ conclusions मिलता है that the energy spectrum of electrons in a crystal consists of a number of allowed energy bands. यहाँ देख रहे हैं ना कि कुछ allowed है और कुछ नहीं है, forbidden है. That is because alpha square is proportional to E. So ये जो क्या है, this is a measure of this is a measure of the energy. Alpha is proportional to E alpha squared. So ये क्या दे रहा है, energy का. तो हम देखते हैं कि there are allowed energy bands. कौन सा है, यहाँ देखिए फिगर में A, B, C, D, they are allowed. और B, C और उसके बीच वाली जगह में they are the forbidden regions. So we have A, B, C, D, for which cos Ka lies between ±1 is allowed and separated by forbidden bands, that is B, C, D. Second क्या है, for a given value of P as alpha A increases, the first term on left hand side of equation 19A decreases and the plot of left hand side approaches that of a cosine curve. The width of the allowed energy bands therefore increases with increasing value of alpha A. Third है, let us now look at the influence of P. P जो था on the energy spectrum. Is P is made 0, the curve of left hand side of equation 19A, ये जो था मेरा, ये जो आपका था, so that ये 19A में जो left hand side था, that shown in and in this figure 3 में जो आप देख रहे हैं, this becomes that of cos alpha A. बस यहाँ पे ये जो cos alpha है बस ये हो जाएगा, ये जब आपका disappear करेगा. The forbidden regions disappear and we have the continuous energy spectrum of a free electron. For P equal to 0, अब हमको आ जाता है for P equal to 0, so equation 19A gives me cos alpha A is equal to cos Ka, alpha A is equal to Ka, and alpha squared is equal to K squared, and that comes to be twice me by h cut squared. So E is equal to h cut squared by K squared divided by 2m, or E is proportional to K squared. That is E के माने ये proportional to K squared है, तो ये क्या है, parabolic. So E के curve जो है is a parabola. As P is gradually increased, the forbidden regions appear, the width of the allowed regions decreases, and that of the forbidden regions increases. In the extreme case, when P tends to infinity, the allowed energy regions become extremely narrow and the energy spectrum becomes a line spectrum. In this case, equation 19A has a solution only if sine alpha A is equal to 0 is equal to sine n pi, n is plus minus 1 plus minus 2, so alpha A is equal to n pi, and this is equal to alpha squared A squared is equal to n squared pi squared, और यहाँ से हमको एनर्जी मिल जाता है n squared h squared by 8 m a squared. This is equation number 21. So this इक्वेशन 19A जो था मेरा, ये जो इक्वेशन 19 बोलते हैं, तो gives the energy levels of a particle in a constant potential box of atomic dimensions. A fourth point क्या है, from figure equation 19A and figure 3, it follows that the energy discontinuous occurs when Ka, यहाँ देख रहे हैं ना, जब Ka is equal to n pi, n pi so k क्या हो जाएगा n pi by a where n is plus minus 1 plus minus 2. So these values of k define the boundaries of the Brillouin zones. The range of the allowed values of k between minus pi by a to pi by a defines the first Brillouin zone. यहाँ पर से देखिए ये यहाँ से लेके यहाँ तक, that is the first Brillouin zone. And then the second zone consists of two parts, from minus 2 pi by a to minus pi by a, and from pi by a to 2 pi by a. Similarly, third zone and so on. Thank you.